Now that we have skills making Scratch simulations and knowledge about how geologic time is organized around major changes, it's time to bring it home to the present day. How much are humans changing the planet? Students consider both the past and the future as they prepare their culminating experience. We framed the first lesson around this phenomenon, thinking about how layers of rock record pages of the Earth's history, and we know that present-day human activities are also leaving an imprint as well. Has there been a big enough change that we've actually should record this as a new epoch in geologic time? That's the debate that students have in Lesson 1.21. They read an article individually about scientists proposing this new epoch of geologic time called the Anthropocene, the epoch of people. After students read the article, they participate in a kinesthetic activity, aligning themselves along a continuum about how much they agree with the idea that the Earth should have a new epoch. Then they meet in small groups to discuss the evidence geologists used to determine new categories of time scale. Finally, students construct an evidence-based argument about whether or not they agree or disagree with the classification of a new epoch, and they participate in this human continuum again. They'll use that thinking in their culminating experience, which they're now ready for. Check out the PDF in Lesson 1.22 for the Culminating Experience Teacher's Guide, and we'll walk through some key pieces of that right now. But this is an online-only exclusive, so make sure to check it out. The deliverable for this culminating experience is a Scratch animation that accomplishes two goals: capture our theme of protecting our planet, and illustrating the science concepts that we discovered in this unit. And here's another way to express that. Every student is required to make sure that their animation includes the theme of protecting the Earth. But then they need to select at least one of the required science elements from these bullets below, organized by a different layer. Many of our students get so excited that they start including a bunch of these. Let's take a look now at an example. In Scratch, we click this green flag to go, and then our students coded in a start button, which we'll click. And there's no sound, so I'll narrate for you as they go. Our astronauts are floating. Jim, I have a question to ask you. What's the question? How do you think we got here? With rockets? No, I mean, how do you think all this got here? The Earth, the stars, our galaxies? Well, it all started millions of years ago. About 13.7 billion years ago, there was nothing but dust particles floating in space. But as time gradually went on, the force of gravity pulled the dust particles together until they compressed and created the Big Bang. The Big Bang formed everything in the universe, including the Earth. Now, this animation goes on quite a ways from here, but we'll go ahead and stop. Now, I know not everything in that animation was accurate, but the way in which they were able to move the particles around and show that gravity brought them together illustrates that they have some good understanding of knowledge and that they were able to communicate that using the computer coding. We have the full rubric in the PDF, but here are the key criteria and the Level 4 anchor statements. The first is about their overall visual communication skills. Are their visuals clear and effective? Then we address the accuracy and completeness of the science content, and how well they capture the theme of protecting Earth's future. The last criteria is about their class presentation of the model and their peer evaluations. So let's walk through the days of how students will get this done. In Lesson 1.22, we introduce the project guidelines and pass out that guideline worksheet, and begin working on the storyboard, the step-by-step sequence of what they want to show in their animation. We end the class with our second unit concept checkpoint. In Lesson 1.23, student groups plan the sections of their simulations and animations in a little bit more detail. They think about what specific visual representation they're going to move around. Now, students need to actually then compile all of those or create them. They can search the web and find images, or draw on paper and scan, or produce computer drawings of each one of those elements that they're going to move around. And for homework, if they haven't finished it already in class, they need to make sure that they've got their full collection of visuals so they can start working on making them go together in the next couple days. In Lesson 1.24, students create a description of the animations in a paragraph form for their viewers. Then they work on drafting algorithms or instructions of code called pseudocode for each one of their sequences in the animation. Days 25 and 26, students start coding and convert their plan into action, and they've got 2 full work days. Since the animations tend to be really rich, we provide 2 full days for students to present their simulations and animations to the class. They explain why they chose key events in their simulation, and they explain their representation of the future Earth. Meanwhile, Peers provide detailed feedback about the animations so that everyone can reflect on their learning. In Lesson 1.29, students take the final unit assessment, and they also study the biography of a prominent LGBT geologist who inspired students to become green ninjas no matter what subjects they pursued in their careers. We've laid down all the layers for this unit. Our next unit builds on this one, looking in more detail at evolution and extinction.